Namaste JVWU, in the Faculty of Physiotherapy and Diagnostic. Today we are going to discuss about the session ultrasonography. It is also called ultrasound in the course Equipment in Modern Imaging Modalities second BSc 4. Let me discuss about the ultrasonography introduction. An ultrasound scan is a medical test that uses high frequency sound waves to capture live images from the inside of your body. It's also known as sonography. Then ultrasound allows your doctor to see problems with organs, vessels, and tissues without needing to make an incision. Next, ultrasonography is the use of high frequency sound waves to generate an image. Sound is a wave of energy that, unlike X ray, must be transmitted through a medium. The frequency of sound waves used in ultrasonography is well above the limit of human hearing, here 20,000 kilohertz. The velocity of sound wave depends upon the nature of medium. Then you can see the image of transducer. It shows backing dampening blocks, and in the top of the transducer it has a crystal, piezoelectric crystal, and the matching layer. The transducer has these components: a cable, housing, damping block, piezoelectric crystal, which is made up of lead zirconate titanate, LZT, PZT, LZT, matching layer. Next, we'll discuss about the principle. Principle of USG is based on the fact that the substances that convert electrical energy to sound energy, vice versa. US transducer contain a crystal which emit high frequency sound wave with response to excitation by an electrical current. This is known as piezoelectric effect. The emitted sound waves are reflected back by tissue within the body. The commonly used crystal is lead zirconate titanate, PZT. Next, the interaction between ultrasound and matter. There are three methods of interaction: reflection, refraction, absorption. Reflection: the percent of beam reflected tissue interface depend on acoustic impedance, and second is the angle of incidence. Reflection can be categorized as either specular or diffuse. Specular reflectors are large, smooth surfaces such as bone, where the sound wave is reflected back in a singular direction. The greater the acoustic impedance between the two tissue surfaces, the greater the reflection and the brighter the echo will appear on ultrasound. Conversely, soft tissue is classified as a diffuse reflector, where adjoining cells create an uneven surface, causing the reflection to return in various directions in relation to the transmitted beam. Or refraction process, it is governed by Snell's law and describe reflection where sound strikes the boundaries of two tissues at an oblique angle. The bending of waves as they pass from one medium to another medium is called refraction. It may cause artifact and loss of resolution of image. Third process is absorption. The term absorption refers to the conversion of ultrasonic energy to the thermal energy. Three factors are determine amount of absorption. First is frequency of sound, second is viscosity of conducting medium, third is relaxation time of medium. So you can see the specular or diffuse reflection in this image. It shows clearly the reflection type. Reflection. Ultrasound transducer converts electrical energy into mechanical sound energy and back again based on the piezoelectric effect. It is the handheld part of the ultrasound machine that is responsible for the production and detection of ultrasound wave. It consists of five main components: piezoelectric crystal, second is positive and ground electrodes, third is backing block, fourth is matching layer, fifth is transducer housing. So, piezoelectric crystal, usually lead zirconate titanate (PZT), may consist of a single element or be a broadband transducer with multiple elements. Element thickness is determined by what resonance frequency is desired, equal to the half wavelength A thicker element produces a lower frequency oscillation, while a thinner element produces a higher frequency oscillation. So you can see the positive and ground electrode in second point. This allows for electrical connections. Positive electrode is in the back of the element, ground electrode is on the front of the element. Next is backing block. Adhere to the back of the crystal behind the positive electrode, absorbs ultrasound energy directed backwards and attenuates stray ultrasound signals from the housing. Uh, uh, so the backing block is made up of resin and okay. Then next is matching layer. Interface between the transducer element and the tissue allows close to the 100% transmission of the ultrasound from the element into the tissue by minimizing reflection due to transversing different mediums, acoustic impedance, so on. Next is transducer housing, electrical insulation and protection of the element include a plastic case, metal shield, and acoustic insulator. Type of transducer, real-time transducer, and second is special purpose transducer. It is further divided real-time transducer into the two types. Mechanical scanning, electrical scanning. Special purpose transducer is also further divided into four types: intracavity scanner, second is intraluminal scanner, third is scanner, fourth is intraoperative scanner. It is based on the type of ultrasound scanning. So, advantage of USG: no harmful byproduct, non-invasive method, relatively cheaper, radiation free. Second disadvantage: doesn't penetrate some object as well as the other technique, air and water. So, ultrasonography. Okay, this session is over. This session is powered by Digital Version 2.0, JVWU Women's University, Jaipur. Thank you.